So it's a question from book Pathfinder under the section Check Your Understanding, and the question number is 19. And the question says like this: there is a ring, there is a particle, both can move freely, and both have same mass. Initially, particle is infinitely separated. Then it is projected with a speed u, and then we have to find the maximum speed of a ring in the subsequent motion. So this is the question. And they both have charge. The ring has capital Q and the particle has a small q charge, both positive in nature. So as shown in the figure, there is a ring and there is a particle, and speed is u, mass same, and suppose u is just enough so that the particle just reaches to the center of ring. So in that case, when the particle reaches to the center, then momentum must remain conserved. And since it is just reaching to the center, it means the velocity of particle with respect to ring is zero. It stops there with respect to ring. It means as seen from outside, both will have same velocity, and that velocity should be u by 2 each, so that momentum remains conserved as there is no force from outside acting on this whole system. So momentum has to be conserved. And so is the energy. So if you conserve energy, so the initial kinetic energy is half mu square, that will convert into kinetic energy of both ring and particle, as well as there is a potential energy given by this expression. And on solving this, we get the value of u, and suppose this value is u0. Suppose, so if u is u0, the particle reaches just to the center and all system moves with a common speed u by 2. So we have, when u is equal to u0, the maximum speed of ring is u by 2. Now, when u is less than u0, again both will have same speed, but the particle now will not reach to the center. Both will have same u by 2, both will have same speed u by 2, but the particle will not reach to the center now because the speed is less than u0. u0 is the speed when particle reaches to the center, and then they have common speed. Now in this situation, both particle and ring will repel each other. They are always repelling. So after this situation, they will continue to repel, and due to repulsion, the speed of this particle will go on reducing, while the speed of this ring will go on increasing. So a time will come when the particle stops and the ring is moving, suppose with velocity v at that instant, and suppose the distance is r at that instant. From momentum conservation, since momentum must remain mu throughout, this ring must have the same momentum as carried by the particle initially. So mv of this ring should be equal to mu of particle, and therefore this ring will move with velocity equal to u, so that momentum remains conserved. And conserving energy, since v is equal to u now, and the kinetic energy of ring is equal to now the initial kinetic energy of the particle, so the energy has attained, when ring moves with speed u, the whole energy has appeared in this kinetic energy form. So potential energy must again go to 0, and that will become 0 only when r is infinity. So when this situation comes, the ring will move with speed u and the particle will stop and the distance will become infinite. So there will not be any further changes. So this ring will have maximum speed equal to u in this case. When u is more than u naught, suppose the particle reaches the center of ring, it will go beyond the center. Suppose when the particle is at the center of ring, it's having velocity u minus v, and the velocity of ring is v. See, the momentum must remain conserved. So since they have same mass, so decrease in momentum of the particle will be equal to increase in momentum of ring. And since they have same mass, so whatever speed is decreased in the particle, the same velocity will increase in ring, so that momentum is conserved. So this is the situation. And now writing energy conservation, we have half mu square equal to half mv square plus half mu minus v square plus potential energy. And we solve this, we get, if you go on checking, just solving and solving for v is equal to this much. And since v cannot be more than u, so we'll have to choose minus sign. So this is the expression for v. This is the velocity of a ring when particle crosses the center of the ring. And this is also the maximum velocity of ring, because when particles cross the ring, they will again repel each other, and in further motion the ring will slow down only because of repulsion from the particle. So this is the maximum velocity, because when particle has crossed the ring, they will repel, and therefore this v will decrease only with time. So maximum speed is v. So again, a question from Olympiad. These questions require a lot of thinking. Okay, thank you.